Hello students, welcome to this class. In this class, we will start the second semester courses and lessons. At this lesson, we will start with chapter 3, lesson 5, a brief revision for lesson 5, which is graph a line using intercepts. We will learn how to determine the intercepts of a line from a graph and then from an equation. So we can use these intercepts to graph the line again. Okay, let's start our lesson today, which will be just a revision of what we have learned last semester. Okay, let's look here at this picture. We can see the blue line here, and this blue line passes through the y-axis. So we can see here that this is the y-axis, here the y-axis, and the line, the blue line, passes through this axis. Okay, at some point, this point we can just represent it as the red point here. Okay, this is the intersection between the y-axis and the line. So what do we call this point here? We call it the y-intercept. The y-intercept. Okay, let's review now how can we determine the coordinates for a point. Let's look at this green point here. Okay, the green point. How can we write its coordinate? Okay, its coordinates can be written as two parentheses. We can open two parentheses, and between these two parentheses there is a comma. So there are two values. The first value represents the x value, and the second value represents the y value. Okay, it's the projection of that point on the y-axis. Let's see how can we determine that. To determine the x coordinate of this green point here, we just see where this point is located on the x-axis, or where it is its projection on the x-axis. We can see that it is here. Okay, there are no numbers on this graph. How can we know what is the coordinate now? We can count the squares, right? We can count the squares. So instead of writing numbers, we can just count 1, 2, 3, 4. So we know that this is 4 on the x-axis. So now what is the x coordinate of this green point? It is 4. So we can write that the x is 4. The first value always represents the x coordinate, and the second value on the right represents the y coordinate. So we can say that this is x here, and this one here is y. Okay, what about the y coordinate for this point, for this green point? How can we find it? Okay, we look at the projection of this point on the y-axis. Where does this point located on the y-axis? It's somewhere here. Okay, there's no number. How can we calculate it? Okay, just as we said, let's just count the squares. We start counting from the origin. 1, 2, 1 and 2 squares. There are only 2 squares there. So this is 2 on the y-axis. Okay, is it positive or negative? Yes, absolutely, it's positive because we are going upward on the y-axis. If we go downward like this, it will be negative. The same thing for the x-axis. If we move to the left, okay, on this left of the origin, it's negative. But because it is on the right of the origin, it's 4 unit positive. So how can we write now the coordinate for this point, the blue point, the green point here? The green point we can write, because the projection of this point on the y-axis is 2, so we write 2 equals the y coordinate of that point. Okay, so what do we call the 4? The 4 here represents the x coordinate of the green point. Okay, what about the 2? The 2 is the y coordinate of the green point. Okay, this is how we represents the coordinates of points. Okay, so let's back now to the intercept. We said that the red point represents the y-intercept. Why is that? Because the line passes through the y-axis at this point here. Okay, let's try to figure out what are the coordinates for this point here. Let's open two parentheses and see what is this point's x coordinate. We can see that the projection of this point on the x-axis passes the origin point. So its x coordinate is 0, while its y coordinate, we can count upward like this. This is 1 square up, 2, 3, 4. So it's 0.4. Okay, this is the coordinate of the y-intercept. Or we can write instantly that y-intercept equals 4. The y-intercept equals 4, and the coordinate for this point is 0x and 4y. Okay, let's move on for another example. Let's take this example here. For this example here, what is the y-intercept for this line? Of course, we can see that this point here, circled by the red circle, okay, it is the y-intercept. Why? Because this is the y-axis, and this one here is the x-axis. The point where this line passes through the y-axis, which called the y-intercept, is this point here. And how much is that on the y-axis? We can see that this is the origin point, and we are moving downward from that origin point, okay? Moving 2 squares, 2 steps down. So it is -2. Okay, so the y-intercept is -2. What is the x-intercept? The x-intercept is the point where this line passes through the x-axis. We can see that this is the x-axis, and this point here passes through the x-axis at this point. Okay, and how much is that? We count the squares. 1, 2, 3. So the x-intercept of this line is 3. Okay, let's move on for another example. This example here, where is the y-intercept? We can see that this line passes the y-intercept, the y-axis, sorry, at this point here. Okay, and it is also passes through the x-axis at this point here, at the same point, right? So they have the same y and x intercept. And what is this point? What is the coordinate for this point? It's actually 0 at x-axis and 0 at y-axis. This is the origin point. The origin point, called the origin point. It has 0 x coordinate and 0 y coordinate. Okay, so this line has the same y-intercept and x-intercept. Okay, and it is the origin point. The origin point. Okay, if you remember from the last semester, we called this function or this equation or this line, okay, you can call it any of these, that passes through the origin point, we call it what? A proportional relationship. A proportional relationship is that the relationship that passes through the origin point. Passes through the origin point. Okay, another thing to remember is that, as we have learned last semester, we just said that the slope for this line, because this line is going downward, it goes from there downward, right? The slope will be negative. The slope will be negative. We're not extremely concerned with slope in our studying today, But let's just review some information that we have learned last semester. Okay, let's just notice some things about these x-intercept and y-intercept. We see that for this example here, this line has a y-intercept of 3, okay, at this point here. And we can just write the coordinate for that point as it is 0. The projection on x-axis is 0 at the origin point, so it has 0x coordinate, and its y coordinate is equal to the y-intercept itself, which is 3. Okay, so this is the y-intercept, this is the y coordinate. Okay, what about this point here, the one in the blue? This point, -4, is obviously the x-intercept, because this is the x-axis, and this point the line passes through the x-axis at this point. So it is the x-intercept. Okay, for the x-intercept, what is the coordination of this point here? It's -4 in the x-axis, okay, and it is 0. The projection of this point on the y-axis is at the origin point again, so it's 0y. The y coordinate for this point is 0. What can we notice? We can notice that at the x-intercept, we have the coordination of y equals to 0. And this is right and always for all functions and all relationships and all equations, okay? All straight direct relationships and equations, okay? The same thing for the y-intercept. Okay, what about the y-intercept? The y-intercept always has an x-coordinate of 0, okay? They are opposite to each other. If you need to the y-intercept, then the x-coordinate will be 0. And if we are talking about the x-intercept, the y-coordinate will be 0. Okay? Opposite to each other. Okay, how can we use this conclusion to just extract and know the intercept, the x and y intercepts from an equation? We now have learned how to find the intercept, x and y intercepts from a graph, and that's easy, right? But how can we just know what are the x and y intercepts for an equation, like this equation here? How can we solve this equation, or how can we find just the x and y intercepts for this equation? Actually, we are going to use the rule or the conclusion from above result to do that. Okay, here's how to make it. It only takes us 2 steps, just 2 steps. Okay, let's just first let's try to find the x-intercept. We need to rewrite the equation here. Y equals 3/4 times x plus 3. Okay, the first step to do here, the first step, what did we say about the x-intercept? Once we have an x-intercept, what is the coordination of y? The coordination of y here, it is 0. We can use this result here. We can say the first step to do is to substitute 0 instead of y. Instead of writing y, we write 0. 0 is equal, and we continue the same equation as it is, 3/4 times x plus 3. This is the first step. So the first step is to write 0 instead of y. Why? Why is that? Because we are going to calculate x-intercept. Okay, what about the second step? Actually, the second step is to solve this equation here. To solve this equation, and we can remember how to solve this equation. Starting by the 3, subtract both parts by 3, and we will left with -3 equals 3 over 4 times x. This is an equation that has a rational coefficient. How can we solve it? The best thing we can do is to multiply both parts by the reciprocal of this factor, the factor of the x. We need to find x. We need to let x alone on one side of this equation. So we multiply both parts by 4 over 3, the reciprocal of 3 over 4. We multiply both parts of this equation. And when we multiply a number by its reciprocal, as here, the reciprocal of 3 over 4 is 4 over 3, the result will be equal to 1. So here, at this term here, at this side of the equation, we only left with x. So our answer will be x equal, or let's just write it on the other side, okay? X equals how much? Negative 3 times 4 divided by 3. We can just cancel 3 by 3. So the answer will be x equals negative 4. What does this result represent? This result represents the x-intercept. We found x, which represents the x-intercept of this line. Okay, guys? So it's simple 2 steps. It's a simple, a simple procedure, okay, with 2 steps. The first step, if we need to, the x-intercept, we need to substitute 0 instead of y, okay? And the second step, just to solve that equation for x, and the value represents the x-intercept. What about the y-intercept? Well, as we have said previously, at the y-intercept, we have 0 x coordinate. So if we need to find the y-intercept of a function or a graph or a line, we just need to rewrite the equation again, okay, and follow the 2 steps. But this time we are looking for the y-intercept. So which value should be 0? We are looking for the y-intercept, so we should substitute 0 for x. X should be 0. Okay, so let's do the first step. The first step is to substitute 0 instead of writing x. So we have y equals 3 over 4 multiplied. What is the value for x now? We substitute it as 0. Okay, that's the first step. Substitute 0 instead of writing x. And plus 3, of course. And the second step actually is to solve this previous equation here, is to solve this equation. And it is a pretty simple equation, not like the previous one. Why? Because it is 3 over 4 times 0, and I think times 0 equals 0. So this term is 0. So we are only left with y equals how much? Exactly, 3. Y equals 3. And what does this value represent? It represents the y-intercept for that line. The y-intercept for that line. Okay? So that line we are talking about have a y-intercept of y equals 3 and an x-intercept of x equals negative 4. That's how to find the x and y intercepts for a line if we are given an equation like this one here. First thing, substitute 0 based on which case you are, and then solve the equation. That's it. As easy as it is. And if you notice, this is the equation that represents this line here. So this line have an x-intercept of negative 4, which we have calculated, and the y-intercept of 3, which we have calculated from the equation. So we did it in both ways, from the figure, and from the equation directly. So we can conclude that this line is represented by this equation here. It is the same for that. Okay, that's it for this lesson. Thank you very much. See you later.